Okay, welcome back again. What I want to look at now is the basic mercury flat cell. Okay, hopefully that can come into full view. Okay, now you'll notice this is a flat type battery cell from that goes into your watches, into your maybe your calculators and so forth. And you can see the construction: steel case, okay, which acts as the positive plate, insulating gasket, okay, zinc, okay, and here you have potassium hydroxide, and you have mercuric oxide, okay, which begins to make up your cell itself. Okay, so let's just go in a little bit closer so you can see it in detail. Okay, let's pull out, pan out. Okay, thank you. Minimize him, open up the other one, okay, and here we have the Leclanche cell, dry cell. Okay, now from what I can remember, this normally operates as a useful source of energy in regards to battery cells. Brass cap, vent, pitch seal, okay, cardboard case, zinc negative case, okay, and you have your plaster of Paris soaked with sal ammonic acid, linen bag, manganese dioxide and crushed carbon. Okay, that begins to set up your, if you break the cells open or cut them open, you'll see that these actually exist as a paste. Carbon positive rod, okay, and that will go straight through that manganese dioxide. Yeah. Just pull back a bit so we can get it all in. Okay, thank you. Okay, next one. Now this is a hydrometer, okay? It's used to measure the acid in your battery cells. That now you would recognize this. A hydrometer would be used to measure the acid in your car battery mainly, okay? It decides on the strength of the acid in the battery, because you'll need that to ensure that you have electrolysis happening within the battery cell and that the battery is functional and good and charging or holding its charge overall. Okay, now here we have, let me see if I can enlarge this a bit. Now here we have the nickel cadmium cell, okay, nickel cadmium cell, okay, and this again is slightly different in the sense that it has a reasonably high current in respect of the voltage. Container nickel plated steel. Now I don't know if these are still in use, so don't hold me to that, but I figured that the information would be useful anyway to have, irrespective as to whether they were in use or not. But you can actually do some research on the internet to establish whether or not nickel cadmium cells is still in use and in respect of the current against the voltage. Okay. Now here we have a typical Leclanche dry cell. Okay. Let me bring it up into full screen. Let me go back a little bit so we can get it fully in. Okay. Now, all it's trying to tell you here is that typical Leclanche dry cell and how it can be used in an electronics for the service engineer. Now, here is our 9-volt battery. Okay. Here we're measuring the voltage across the circuit at the initial stage, and you have your voltmeter set from 0 to 10 volts. Okay. Here is our switch. You put the switch in. That's your amp meter. It will measure the current that's flowing in the circuit once you have made switch S1. The ohms resistor here is 15 ohms. Okay. And you can see that here we have available resistor 1K. And all this does is to control and illustrate the current that will flow in the circuit by when we vary the resistance of the circuit in itself, and how that will have an effect on the voltage. And that is in respect of our Leclanche dry cell. And here we have nickel cadmium cell. Okay, now this type of battery is normally a 2-volt battery, but the current it holds is tremendous. Okay, it carries a very high current. Okay, and this would normally be called your secondary cell. Let me just take it up to full screen. Okay, now we can get all the information in that we can. Okay, so secondary cell, and here would be your 2 terminals. Now, I know a little bit about this because we used to use this on the diesel multiple units on trains, and they're quite heavy batteries, quite large, and they had to be loaded onto your trains by a stacker truck basically, but the current is quite high even though the voltage is only 2 volts. And I believe these are these cells, nickel cadmium cells. Again, do additional research for yourself in respect of each of these cells. Get familiar with what they actually can and cannot do. Okay, and you'll be surprised at what you can discover by purely research. Now, closed-top stationary cell dismantled to show construction. All I'm showing here is the construction of the cell itself. Okay, so again, nothing too overexciting. Okay, it just shows the makeup and how it is encased in the casing that in which it comes. Okay. Now here, simple electric cell, and we have a glass container, zinc negative plate, copper positive plate. Okay, we have diluted sulfuric acid, which is the electrolyte, and this, when you put a voltmeter between it, you'll see that actually generates a voltage. You can actually apply this to a little 3-volt 2-volt lamp, and it will actually light, depending on the voltage, of course, being generated at that point in time. Okay. Okay, good. And here we have Leclanche cell. Now this is a wet cell, okay? And again, let me just go in closer to bring in so we can get more detail of it, okay? And I'll just pan out a little bit more. Yeah. And it's a Leclanche wet cell. Again, these are quite useful battery sources, and they can provide a portable source of energy, okay? Okay, now all this does here, it tells you a bit. Let me go in to take from the top as much as I can. Tells you a bit about each battery in turn and how battery operated equipment advantages and disadvantages, etc. And that's all it does, okay, at this point. It makes you aware of the limitations of batteries as a source of energy. Now this is a ramp generator, and the reason for this is that we would use some type of battery source to provide energy in our breadboards and so forth. And all I've done here is to bring this into play as a electronic circuit which we would normally use. Now that's our sawtooth waveform which is generated from the ramp generator, okay? And that would be your output points here, of obviously from here to here. And you would put that, if you put this through an oscilloscope, you actually see how this waveform would be generated, okay? Also, this is called a sawtooth waveform as well. Okay. Now, all I've done here is just show you some waveforms. Sawtooth waveform, square waveform, and this one I should have put a name to it, of course, but I'm going to leave that one for you to research yourselves. Okay, I can't do all the work for you, you know, can I? But nonetheless, I hope you would have found this useful, because I know I did at the time when I was presenting it to my students, because most of it had to be written by myself as well. Okay. Okay, thank you. I hope you found this useful, and we'll speak again soon. Thank you. Bye-bye.